Welcome to Alternative Egypt, the channel that gives a voice to the myths and legends of our ancient ancestors. We appreciate you leaving a comment on our videos, and please don't forget to like and subscribe to the channel for more alternative views on our ancient past.
Our Earth. Each day it rotates around its polar axis, causing the sun and the stars to rise in the east and set in the west. A constant, never-ending pattern. Steady, predictable, reassuring. But what if this was not always so? Dozens of ancient texts from cultures all across the world appear to tell a different story, a deeply unsettling story. In many of these texts, it is said that after a long period of time, the Earth suddenly and rapidly reorients itself, whereby the sun and stars then rise and set on opposite horizons. Plato, for example, writes in The Statesman of how the cosmos changed its orientation and began rotating in the opposite direction, which naturally implies that it was the Earth itself that had begun to rotate the opposite way. When this cataclysm occurs, Plato further writes in the Timaeus that people become like children, remembering nothing of what had happened in ancient times. Our modern science assures us that it is simply not possible for the Earth to behave in such a manner, that the planet cannot invert itself. But what if our science is wrong? What if it has missed something? Some deep, nuanced detail in its understanding of the physics of orbital mechanics as they relate to our planet? Our story begins with the ancient Egyptian legend of Surid, an ancient Egyptian king believed to have lived before the Great Flood. One night, Surid had a dream in which he saw that the earth had overturned and that the stars in the heavens had moved from their normal paths across the heavens. Fearful of this, Surid then instructed his best astronomers to measure the height of the stars, to determine if they had changed, and to see what this change might mean for his kingdom. The astronomers performed their task and later informed the king that in 300 years' time, a great flood would drown the entire country, destroying everything. To mitigate against this looming catastrophe, Surid mobilized his entire kingdom and embarked upon a massive disaster recovery plan. This included the construction of the Giza pyramids, into which he would store everything that would be required for the kingdom to be reborn again after the floodwaters had finally receded. If the true purpose of the Giza pyramids was to safeguard civilization against a cataclysm, then their builders were not simply architects. They were custodians of memory, of knowledge. Knowing that future generations might inherit a shattered world and have little understanding of how it came to be that way, they would have needed a way to communicate across vast stretches of time. It stands to reason that the story of the catastrophe and when it occurred would have been among the most important knowledge they could preserve, especially so if they believed this event, as Plato tells us, was cyclical. The possibility we are exploring here is that the monuments of Giza were designed to encode a record of a past Earth inversion event, a silent testimony written not in words, but in immovable mountains of stone, in geometry and astronomy. But how might such critical data be encoded into the Giza monuments? The first obvious thing to consider is their layout and relative relationship to each other, seen in this overhead plan view of the plateau. Highlighted here is the Great Pyramid of Khufu, known also to Egyptologists as G1. In the center of the plateau stands the Pyramid of Khafre, often mistaken for the Great Pyramid, and known as G2. Finally, of the three main pyramids stands the smaller pyramid of Menkaure, or simply G3. These are the three main Giza pyramids, the giant pyramids. On the eastern side of the Great Pyramid are three small satellite pyramids, believed by Egyptologists to be pyramids of Khufu's queens. On the southern side of Menkaure's pyramid, we have a further three satellite pyramids, also believed to be pyramids of the queens of Menkaure. And finally, on the far right of the plateau, sits the Great Sphinx, known in ancient times as Horem Akhet, which means Horus of the two horizons. According to Egyptology, the pyramids of Giza were built as largely independent monuments, their positions and dimensions determined by the individual pharaohs who commissioned them. No grand, overarching design is believed to underlie the layout of the plateau. Beyond a possible alignment toward Heliopolis, the size and placement of the pyramids is generally regarded as little more than a series of separate decisions made over time. But a closer look tells a very different story. Even the simplest geometric analysis reveals that these monuments are not randomly sized or arranged. They appear to form part of a coherent and carefully conceived design, one so obvious that its implications are difficult to ignore. If so, then Egyptology has overlooked a crucial piece of the Giza puzzle hiding in plain sight. Returning to the ground plan of Giza, one feature immediately commands attention: the so-called Giza diagonal, a theoretical alignment of the Giza pyramids first identified in the 1980s by Egyptologists Mark Lehner and Hans Godijk. This alignment begins with a diagonal through the axis of the Great Pyramid's first satellite pyramid, extends to touch the southeast corner of the Great Pyramid, moves across the plateau, narrowly misses the southeast corner of the middle pyramid of Khafre, travels onwards to touch the southeast corner of Menkaure's pyramid, and finally passes through the axis of Menkaure's first satellite pyramid. 6 significant points, all connected along the same line. With the very peculiar exception of G2, Khafre's pyramid. Significantly, this is not the only time this pyramid resists falling into line with the others. It also refuses to integrate cleanly into other geometric patterns across the plateau. Among these are a network of lesser-known relationships, what we may call the pyramid interquarter lines. Extended across the site, these lines connect key features in a way that links the Great Pyramid and Menkaure's pyramid, while also intersecting the diagonal axes of G3's satellite pyramids. Had either of these two monuments been placed or proportioned even slightly differently, the interquarter relationships would vanish. This can be viewed as a strong indicator that G1 and G3 pyramids are in their correct plateau positions. That is to say that we should be treating these two pyramid centers as the anchor points for the Orion-Giza correlation, a grand overarching design in which position, scale, and proportion were carefully coordinated. Yet G2 stubbornly refuses to fit in with the geometry that so clearly binds the other two pyramids. It does not sit cleanly on the Giza diagonal. It does not integrate into the interquarter line matrix. And it does not align with its stellar counterpart star, Al-Nilam. It is almost as though G2 preserves the memory of a different configuration, an alternative arrangement, which raises a curious possibility. Perhaps the G2 we observe today was not originally planned to be at its eventual location. Perhaps like G1 and G3, Pyramid G2 was also originally conceived to be positioned in precise relation to its stellar counterpart star, Al-Nilam, but that the designers, for some underlying and important reason, felt it necessary to offset this pyramid slightly from its planned belt star ground position? If this is so, then the hypothesis is predictable and easily testable. By restoring G2 to its central position of Al-Nilam should, in theory, resolve the inconsistencies associated with this pyramid. Incredibly, when this is done, something quite remarkable occurs. The offsets, all of them, vanish. The diagonal discrepancies disappear. The interquarter relationships suddenly click into place, fitting like a glove. The awkward geometry of G2 now completely resolves. But there's more. When the pyramids are considered alongside their satellite structures, together, the Giza pyramid field presents three extreme outer points on the plateau: here, here, and here. Using these 3 points, we can draw a circle around them, a Great Giza Circle. And circles are not arbitrary. They have centers, and centers imply intention. So where does the center of the Great Giza Circle fall? Not at the Great Pyramid, not at the Sphinx, not at the geometric center of the plateau, but at Al-Nilam, the center belt star. And also, of course, with G2, when restored to its proposed original planned position. At this point, the geometry becomes completely unified. The infamous misalignment error of G3 dissolves once the outer stars are used as anchors. If the geometry only resolves when G2 is repositioned, was its current location always intended? Or was it deliberately altered after the broader design had already been established? Perhaps the offset of G2 was never a mistake. Perhaps its relocation was deliberate. Further evidence suggests that this possibility is almost certainly correct, and that G2 was indeed relocated from its Al-Nilam center for a very specific and startling reason, which we will come to later in this video.
These two features of the Giza monuments, the Giza Diagonal and the Great Giza Circle, are absolutely central to understanding what we might call the Giza Code. For it is here, encoded within stone and geometry, that the ancient architects appear to have embedded a remarkable body of knowledge, a record of the Earth inversion event, the extent of that upheaval, and, perhaps most astonishing of all, the means by which its recurrence might be determined. But how was such information conveyed? To answer that question, we must look more closely at one of the most enigmatic monuments ever created. Earlier, we noted that the ancient name of the Great Sphinx was Horem Akhet, Horus of the Two Horizons. Such a title was almost certainly no arbitrary designation. Rather, it may reveal the very purpose of the monument itself. The Sphinx was, in effect, a marker of a horizon, not merely the visible horizon, but one conceived in symbolic terms and represented by the Great Giza Circle itself. And when we begin to view that circle not simply as a geometric boundary enclosing the pyramids, but as a symbolic 360-degree horizon embracing the entire plateau, a fascinating possibility begins to emerge. For this terrestrial frame of reference serves a highly specific purpose. It allows us to determine the orientation of Orion's belt as viewed by the ancient designers and expressed on the ground by the Giza monuments. The choice of these stars is significant. Orion's belt is one of the few easily recognized stellar formations that straddles the celestial equator and can be observed from both the northern and southern hemispheres, albeit with opposite orientations. Indeed, it is entirely possible that this unique characteristic was precisely why the ancient designers selected Orion in the first place. The decades-long debate between Robert Bauval, originator of the Orion correlation theory, and archaeoastronomer Dr. Ed Krupp reveals the heart of the problem. The layout itself cannot decisively favor one orientation over the other. Both remain geometrically viable. Some further key is required, and perhaps the ancient architects anticipated this very dilemma, leaving behind the missing piece in plain sight. A vast theoretical horizon implied within the monuments,
a symbolic frame against which the celestial pattern was intended to be understood. The Great Giza Circle.
And the following is perhaps how the ancient design was intended to be understood. When Orion's belt is observed due south from the Giza Plateau, the three stars do not rise to the same height above the horizon. Each occupies its own distinct altitude. In our present epoch, Al-Nitak, the stellar counterpart of the Great Pyramid, appears nearest to the horizon, while Mintaka occupies the highest position, furthest removed from the earth below. Clearly, the architects of Giza could not reproduce this arrangement literally. They could not stack the pyramids one above another in imitation of the sky. Gravity forbids it. But what they could do, and what they may indeed have done, was create a symbolic horizon and arrange the terrestrial counterparts of the belt stars relative to that horizon. In this interpretation, the Great Giza Circle assumes a profound significance, functioning as a stylized representation of the boundary between earth and sky. Seen in this light, a remarkable pattern emerges. The northeast corner of the Great Pyramid appears to be anchored directly upon this symbolic horizon. In other words, it occupies the position closest to the ground, closest to the horizon itself, just as Al-Nitak is the lowest of the belt stars when viewed from Giza. The other two principal pyramids, G2 and G3, lie progressively farther inward from the Great Giza Horizon Circle, and thus are to be viewed as being progressively farther from the Earth. They correspond, therefore, to Al-Nilam and Mintaka, whose greater altitudes above the Giza horizon are mirrored in stone by their increasing distance from the Earth-sky boundary. What this implies is both fascinating and unexpected. It suggests that it was Robert Bauval's perspective of Orion's belt, as viewed upon the southern horizon of the northern hemisphere, that the ancient architects chose to encode at Giza, and not the inverted perspective championed by Ed Krupp. Yet this does not mean that Krupp's famous observation that the Earth itself would have to be overturned for the Giza-Orion correlation to work was entirely mistaken. On the contrary, he may have been closer to the truth than he ever imagined, just not for the reason he supposed. All of which raises the obvious question: why? Certainly, the Great Giza Circle appears to settle the dispute between Bauval and Krupp. But such a controversy, played out thousands of years after the pyramids were built, could hardly have been the concern of the ancient designers. Their purpose must have lain elsewhere. Could this symbolic horizon have been intended to convey something deeper? Something far more profound? It seems that it was. And if so, we are confronted with what may be the most astonishing revelation of all. To understand it, we must return once more to the Giza diagonal. Like the Great Giza Circle, this enigmatic line appears to serve a very specific purpose. Notice that its extremities pass directly through the axes of G1A, the first satellite pyramid of Khufu, and G3A, the first satellite pyramid of Menkaura. In effect, the line binds together the same member of each pyramid triad. It is as though the architects are saying, "We have bound these two structures together because they represent the same star of Orion's belt." But which star? Since both pyramids occupy terminal positions within their respective triads, they could signify either Al-Nitak or Mintaka. Which interpretation did the builders intend? Once again, the answer reveals itself through the agency of the Great Giza Circle. Observe that the northeast corner of G1A, just like that of the Great Pyramid itself, rests precisely upon the symbolic horizon. Therefore, just as the Great Pyramid in this configuration corresponds to Al-Nitak, the lowest of the belt stars when viewed from Giza, so too must G1A represent Al-Nitak. And because the Giza diagonal explicitly links G1A with G3A,
we are compelled to conclude that G3A must likewise signify Al-Nitak and not Mintaka. And it is here that the implications become truly extraordinary. For while the Khufu satellite complex shows us Al-Nitak as the belt star nearest to the symbolic horizon, on the opposite side of the plateau, an entirely different picture emerges. There it is not Al-Nitak, but Mintaka, represented by pyramid G3C, that occupies the position closest to the horizon. The order of the belt has been reversed. It has undergone a complete inversion, 180 degrees. And this, perhaps, was the deeper message encoded within the geometry of Giza. The Great Giza Circle and the Giza Diagonal, working in concert, appear to demonstrate something both remarkable and deeply unsettling. Not merely an inversion of the stars, but a symbolic representation of an inversion of the Earth itself. If this interpretation is correct, then the architects of Giza were not simply memorializing the heavens. They were preserving the memory of a catastrophe, a world turned upside down, and encoding that memory in stone for the benefit of a distant future that, one day, might finally understand what they were trying to tell us. In part 2 of this video, we will see how the star shafts of the Great Pyramid serve to precisely corroborate this Earth inversion event that appears encoded in Giza's 2 sets of satellite pyramids.
This video presentation is based on the research of independent author and researcher Scott Crichton. His books are available on Amazon.com and from all good bookstores.